I'm going to now try to explain extrema from a pictorial representation and show what the definitions are trying to convey. There's x, here's our function. All right, maybe something like that. Put a few locations on here. D, C, B, and A perhaps. So it looks like the domain of our function, if we had to describe it with the little information we have here, would be the closed interval from A to D. All right, so dealing with absolute extrema first. Absolute extrema, you look across the entire domain. So I look across from A to D in totality, in a global fashion, and I look for the lowest and highest values for the function. Okay? So it looks like the lowest value is happening over here. So I would say that the absolute minimum could be labeled right here at this location. Here's our absolute minimum. It's happening at x equals A. And the largest value in here is happening at D. So there's our absolute maximum. Functions don't have to have an absolute minimum or a maximum. I've drawn this one so that it does, because I'm trying to exhibit what it may look like. Absolute maximum here at x equals D. And anytime you're talking about extrema, whether it's relative or absolute, the absolute maximum or absolute minimum is always referring to the function value. So the absolute minimum here is whatever function height this is. I don't feel like labeling these right now, but that's the idea of the terminology absolute minimum. It's talking about the function value. But where it happens, when it says at somewhere, that will always refer to the x value of this point. All right, so the relative extrema, let's see if there's any here. If there are any, I should be able to construct an open interval, a subset of the domain. So there we go, open interval, subset of the domain. And I map that up to the function conceptually. I'm doing it in writing as well, but this is what's going on conceptually with these definitions. And I look there. There's a new open subset, but it's of the function values now. Okay, so an open subset, an open interval of the domain ends up constructing an open subset of function values from the range, you might say. And I simply look at that, and is there a location within here where the function reaches a highest or lowest value? So in this case, yes, certainly. There is a highest value on this interval of function values, and it is right here at the peak, right? At the apex of this peak that we see in our picture. Okay? So since I was able to find a highest value within this subset, which was constructed from here, then this is termed a relative or local, I guess the book likes local more than relative, local maximum. Okay? That local maximum is happening at x equals b. Again, local maximum refers to the function height there, and the location refers to the x-coordinate where this is happening. Okay, so if that's a local maximum, which you should notice again, it's basically like a peak in the curve somewhere, then probably down here at this trough, right, at C, this must be a local min, which makes perfect sense. Okay, so I'm going to draw another open interval over here containing C. And I drew this one to where it was symmetric about B, but it doesn't have to be. I can draw it this way a little bit and this way a little bit more. It doesn't really matter, as long as you can construct an open interval. So now we have these corresponding values here, right? Again, an open interval of function values. Is there a lowest or highest, but I guess we're looking at lowest in this case. Is there a lowest value within this set, this subset of function values? The answer is yes. It's the very bottom of this trough. all right, happening at the value c. So we have a local minimum at x equals c. All right. So again, you have to be able to construct an open interval in which there is a smallest value or largest value in the corresponding interval of function values, and then you will have a local max or minimum.